Hello guys, welcome back to learning microcontrollers. In this video I'm going to show you how to interface a push button with a PIC16F877A microcontrollers using digital input output pin. So let's get started. For using a push button we have two possibilities, either we send 0 or 1. So when we are sending a 0, what we do is that we need a push button. You can use any type of push button found in the market. I'm using this small push button. This is our PIC16F877A or any MCU. This is a 10 kilo ohm resistor needed to interface the button with a microcontroller, and this is a 5 volt supply. You can give 5 volt from any source, a PIC kit or anything. So let's do the connections. You connect negative of the supply with the one pin of the push button. The positive of the supply goes to one end of the 10 kilo ohm resistor. From the other end it goes to the other pin of the push button. From this other pin we take our output. This is when we will press the button, a 0 will be sent. You can use any available digital input output pin of the PIC16F877A for this. So in case we are sending 1, rest remains the same. Only difference is that positive will go to the one end of the push button while resistor is at the negative end. We will be grounding the negative pin as the other pin of the push button using a resistor. Rest will remain the same. In this way we will get 1. So we will use any available digital input output pin to program this 1 accordingly. So let me give you a demonstration. I am going to use the logic of 0. I will send a 0 to the PIC and then it will be used to blink an LED. So let's get started. This is our push button. This is a 10 kilo ohm resistor. I connect one end of the one pin of the, you can say, push button with a ground, and the other pin goes to one end of the 10 kilo ohm resistor, and from the other end of the 10 kilo ohm resistor we send it to VCC, that is 5 volt. Now from the second pin which we connected with the resistor we take our output, and that is 0, and I am using pin number D2, that is pin number 21 of the PIC16F877A. D2 is a digital pin and it can easily read letter 0, or you can say value, lower value, that is 0 coming from the button. Now to blink an LED I am going to use an LED. It has 2 pins and it needs a 330 ohm resistor to interface with the PIC. We connect the smaller pin of the LED with the ground. The other larger pin goes to one end of the 330 ohm resistor, and from the other end of the resistor it goes to pin number B7. You can use any available digital input output pin for this too. I am using pin number B7, that is pin number 40. Now let me show you what will happen when our program runs. Whenever we press this push button, LED will turn on, and as soon as I release the button, LED will turn off. And for again, when I press the button, LED will remain on for as long as the button is pressed. Leaving the button will turn off the LED. So this is what this program is going to do. So let's get to the programming. This is our MikroC for PIC. Let me zoom it in. Go to File, New Project. Click on Next. Give name, button LM2. I am giving this name. PIC16F877A is the one I am using, and I am using a 20 MHz crystal. Click on Next, and finish. First of all, we initialize the LED pin as an output pin. Trace B is equal to 0. Trace B dot F7, that is pin number 7, is equals to 0. It means that pin B7 is an output pin, while the initial state dot F7 equals to 0. That initially this pin must be 0. LED must be off. Give some initialization delay. It will do fine. Now we declare the button pin as input. Trace D dot F2 equals to 1. 1 means input, and initially F2 equals to 1. It means that, and also give some initialization delay. Okay, this means that trace B dot F7 equals to 0. It means an output pin, but when we are using 1, it means an input pin. It means that it will receive a value, it cannot deliver a value. So initially it's 1 because we are using 0 logic. Initially it must be at 1. Only when the button is pressed this pin will turn 0. Now let's get to the forever loop. While one forever loop starts here, ends here. Give it a nice shape. Okay. Now first of all write if port D dot F2, the pin at which the button is attached, double equals to 0, like 0 is received, then LED turns on only when the 0 is received. Port B dot F7 equals to 1. Okay, LED is on when a 0 is received. Else LED is off. port B dot F7 equals to 0. Okay, LED turns on only when the 0 is received, and it's off when 0 is not received. Now for the button debouncing, actually accidentally there is a possibility that button may debounce, resulting in random values. What you do is that you simply copy paste this, paste it again, you give some safety delay. Like if there is a little disturbance of 100 milliseconds, it will be ignored, it will not turn on the LED. Give double ending bracket. Okay, now it's great, it's gonna work fine. Okay, now let's burn this in the PIC. Let me introduce you to the hardware. This is our hardware. Here, this is the push button I am using. This is my 10K resistor push button, and that is the PIC16F877A I am using. This one is the LED I will be using to demonstrate this project. So go to PIC it, erase any previous program found in the PIC, check the name of your code, button LM2, go back, go to import, this is the code. Now burn the code. Okay, the program is being burned. We are using B7 pin, and B7 is a PGM pin, so this causes the LED to blink while read or write operation. Okay, now our program is running. Now I simply see nothing is happening, because initially we had given a state that whenever nothing is pressed, LED must not turn on, and initial state of the LED is also 0. When I press this button, let's see what happens. LED turns on. See, LED is on for as long as I keep on pressing the button. I release the button, it turns off. Okay, see, it turns on when I press this button, and turns off when I leave it. I press it, it turns on, and when I leave it, it turns off. See, okay guys, so as you can see, our code is working as planned. So in this way we use a zero logic button to interface with the PIC. I hope you guys learned something from this video. Thank you very much for your time, and goodbye until the next video.